All right. So now we have our roots. And what did we do before when we were factoring? What did we do with our roots?
Those are when it crosses the x-axis.
It is, yes. So these are actually 2 points, right?
Mm-hmm.
What are our 2 points?
-3 plus square root of 2. 0.
Comma 0. All right. What's our other point? Someone else? What's our other point?
-3 minus radical 2, comma 0.
Uh-huh. Good. Okay, so we've got 2 points already. That's a really good place to start. But what was that other thing that we needed?
Vertex.
Vertex. And how do we find the vertex?
Divide that by 2.
Average. And even though it's going to be messy, we're going to try it anyway. Okay, so who can give me an equation that I would use to find the vertex here using these roots? Add them. So what am I adding? Little ladder. Little ladder?
Plus -3 minus 2, all of the 2.
Oh, actually, that's not bad.
Okay, and what happens?
It's just -3.
Isn't math beautiful? What happens? Yeah, my grade 2's cancel out, don't they? So I have -3 plus another -3, so I get -6. And that equals -3, right?
That's so much easier.
Ah, okay, so this is my x component of the vertex, right? So how do I find the y?
Plug it back in.
Plug it back in. So what happens? I get -3 squared.
-2.
Plus 6 times -3 plus 7. And who can do that out for me? Who knows what this is? -2. -2, okay. So now I have 3 points, right? I have my 2 roots and my vertex. Okay. I have, let's see, is it easy to graph these points? No. Can we do this exactly, just using the top of our heads? No. Okay, so let's round a little bit and just pretend it's good enough, because the equation shows us all of the exact information that we need, and then the graph is kind of a visual representation. So if we can get pretty close, that'll be good. Our -3 is right here, yeah?
Mm-hmm.
What does root 2 equal?
1.7.
I'm hearing different answers.
It's 1.4.
1.4.
1.4.
Oh, it's like 1.42.
Good. 1.4. So if I'm going 1.4 to either side, maybe that would be roughly here and roughly here. Does everyone agree?
Yeah.
Okay. And then my vertex was -3, -2. -3, -2. And there we go. Does this look like we did over here?
Yeah.
We got -3, -2 as our vertex over here too, right? Now I have a question for you. It seems like a lot of work to have to do all this out and to find the averages of really messy stuff, because who knows if the messy stuff is always going to come out prettily. Pretty. If it'll be aesthetically pleasing to do all this. Do we notice anything interesting in our x term right here? And any of the terms in the solution of our quadratic equation?
Oh my God, this is stuff before the business.
The stuff before the business.
The stuff before the
Stuff before the nasty part.
The stuff before the business. Can you elaborate on that a little bit? Who said stuff? Did you say the stuff before the business?
Yeah, the business is whatever's in the square root.
Okay.
So you just get rid of it.
I can cover it up.
Yeah, because the -3 comes from the -6 over 2. So
Oh, okay. Who wants to elaborate on that? Shara?
It's because you have the plus and the minus, and so when you add, like this, the signs stay the same.
Like
you're
that?
adding it, so since they're opposites, they just cancel out.
Good. Do you think that'll happen every time?
Yeah.
Because every time you're going to have this plus and this minus going on, right?
Business.
Okay. So if we look back at our equation up here, what part of the equation was going to cancel out? All of this stuff. Right? So what are we left with?
Good word.
-B over 2A.
Yeah. Okay. So we just found out a really fast and effective way to find the x term of our vertex. We know that, oh goodness. Okay, well add this to our notes over here. We know the x term of our vertex is what?
Negative b over 2a.
Yeah. So much faster than having to either graph it or go through all this and average messy things. You can just look at your original equation up here. Bam, negative b over 2a. I have one of the pieces of my vertex already. Okay? All right. Now, let's look at this same problem by means of completing the square. Because we know that we can always use different methods. Yes, what's your question?
I have a question.
Yeah.
So do you have to do any of that? Can't you just find it from the square root then, and then just add it? Can you find your other 2 points? So you don't even have to do any of that? Or does it not work that way?
Can you say that one more time?
So, like, you know how we want to make it so much easier, and you just did that? But you still have to do the whole quadratic formula to find your root. Can you just look under the square root and find, like, go that much more over from both sides?
That's-
Like, make it easier?
That's interesting, right? Because what you're saying is if we find the vertex, we know where this point is going to be. So this is now your number 1, right? Rather than having your roots be your first step.
Right.
This is like the old number 1, this is the new number 1.
Right.
So if we're saying we want to do this, can everyone look up here quickly? I hear some chatter and I'd love for you to hear this because this is a really good point. We have before was our old number 1, was finding roots. Now our first step, Cher is suggesting that we find the vertex. And from looking up from the vertex, we can just look at our discriminant, right? The business, and we know how far to move from side to side. What do we think about that? Is that an effective way? Yep.
No, because you forgot about the 2a.
Oh.
Because the minus b over 2a, so you can use that, but you still have to divide it by 2a. So you want to
I agree.
Yeah. Okay.
So you just do it in parts.
Any other comments or questions? Yep.
This is just about graphing. Do we care about the root? Why can't we just find the vertex and then plug in easy numbers like we started with?
Well, I guess that's kind of the process of being consistent. Because if we have a whole slew of different things, it's really consistent to say, okay, here are my intercepts. Because remember how we always chose the y-intercepts when we were graphing linear equations?
Does it matter? We just need 3 points. Does it matter what 3?
That's kind of what Carrie's asking. Do we have to find our roots or can we use other things? In general, the math process follows that you find the roots. It's a really interesting question. I'll look it up to see if we have to, but generally I would suggest doing that just to be consistent. So when I'm looking at your work, if I'm looking at 100 of my kids' tests and everyone's doing it differently, the more consistent everyone can be, the better. But yeah, maybe that would be a good thing. Maybe we can explore that a little more in the upcoming weeks. Yeah?
Couldn't you figure out the x coordinate of your vertex and then just plug in x's on either side of that value?
That's what I'm saying. The x
Because then you'll get your vertex and then you'll get an x on each side. So it doesn't even matter
If
if
it's the
one's
one.
way up here and if one's down here.
Right, that's kind of what we were just saying, I guess in different terms. Do we want to find our roots or do we want to find something maybe down here or maybe up here or something like that? Yeah, once you get your vertex and 2 other points, you're going to have a consistent parabola that follows the rules of your equation. Sometimes it's just easiest to go with the roots because we always know that's on our line. And when we're drawing stuff like linear equations, we always find this just to be consistent, to be like, hey, we know where something on our axis is. Yeah.
But if we always know it's symmetrical, don't we only have to get like half of it?
And then just symmetry to find the other half.
Gosh.
That's another way to do it too. Yeah. Yeah, these are all great methods of being able to graph. Yeah, they all definitely work.